This is Algebra 1, Lesson 5.3. We're looking at rate of change and slope. So let's start with our warm-up. We're going to find the x and y intercepts first. And remember, we talked about in the last lesson, finding the x and y intercepts. If we want the x-intercept, we're going to plug 0 in for y. If we want the y-intercept, we're going to plug 0 in for x. So I'm going to do my x-intercept first. So I'm going to have 2x minus 5 times 0 equals 20. This goes away, so I'm left with 2x equals 20. Divide by both sides by 2, and x is equal to 10. For my y-intercept, I'm going to plug 0 into x. That goes away, so negative 5y equals 20. Divide both sides by negative 5, and y equals,
please come to the high school office.
Sorry guys, they're making an announcement, equals negative 4. Okay? Second part, describe the correlation shown by the scatter plot. Does it look positive or negative? Well, if you notice, we can't make a perfectly straight line with these points, but we can do something that's called a line of best fit. You might have heard this in science, where we can kind of look and see where would our line fall if we could draw one. And if we could draw a line, it would fall somewhere in there. And we have to decide, is this going to be a positive or negative correlation? Well, as you move over an x, as your x values go up, as they get more positive, your y values are actually getting lower and lower. So they're going down. So because those are going down as x is going up, this is actually a negative correlation, okay? So today we're going to look at rate of change, rise, run, slope, finding the rates of change and slopes. So the rate of change is a ratio, okay, or a fraction that compares the amount of change in the dependent variable to the amount of change in the independent variable. So we can write this out as the rate of change is equal to the change in the dependent over the change in the independent. You guys might remember the dependent variable is another word for your y values, okay? And the independent variable is another word for your x values. So this is just your change in your y over your change in your x. I should write change up here so you know it's not just y over x, it's the change. So let's try an example. This table right here shows we have some months going on here and the temperatures of those months during those months in a city in degrees Fahrenheit. And it asks us to decide during which time, it says during which time is the temperature increase the fastest. But first let's decide what's our dependent and independent variable before we can decide that. So our independent variable is the one that can stand alone, the one that does not depend on anything else. So those are your months, because those don't depend on anything else. And then obviously what's left are your temperatures, but you can think about it this way. The temperatures depend on what month we're in. That's why it's the dependent. So now we're going to find the rates of change. And remember, our rate of change is equal to our change in our dependent, so our change in our y. We haven't seen that here yet. The change in our dependent over the change in our independent. So that's going to be our change in temperatures over our change in months. Okay, so for this first one, from 2 to 3 months, it went from 56 to 56 degrees. So it's 56 minus 56 over our change in months, which was 3 to 2. So that's a change of 0 over 1, so our change is 0. So notice how I take the second one and subtract the first one. So our change in temperatures from 3 to 5, if you look on your chart, from 3 to 5 months, it went from 56 to 63 degrees. So the difference in that is 63 minus 56 over our change in months, so 5 minus 3 months. And that is equal to 7 divided by 2. And if you divide that out, that comes to 3.5. From 5 to 7 months, the temperature jumped from 63 to 71 degrees. So we're going to go from 71 minus 63. And we're going to take 7 minus 5. So it's our second minus our first. And that is equal to 8 over 2, which simplifies to 4. So our rate of change there was 4. And then from 7 to 8, it went from 71 to 72 degrees. So 72 minus 71 over 8 minus 7. So that's just 1 over 1, which is 1. So our greatest change was 4, which is from month 5 to month 7. So here's a graph of the data showing you the rates of change. And if you notice, the vertical segments right here are showing you the change in your dependent variable, so how much the temperature was going up. And the horizontal lines, those are showing you the change in your month, so how much the month changed. And then again, you'll notice that the greatest rate of change is the steepest slope. So from 3 to 5 months, which is back all the way from here all the way up to there. So that's your steepest slope. If all the connected segments have the same rate of change, meaning it makes a straight line, that means they have the same steepness of the line, and we would call that a constant rate of change of the line or the slope of the line. The rise of the line is just your difference in your y values, and the run is your difference in your x values. So we can write out slope is equal to the rise over the run, or your change in y over your change in x. And remember, y is your dependent and x is your independent. So if you look over here, if I'm going from this point right here to this point right here, my rise is 3 and my run is 2. So my slope would be my rise, 3, over my run, 2. So my slope of this portion right here is 3 over 2. And in this case, it's the same for the whole line because it's a perfectly straight line. So we're going to find the slope of this line, okay? Now again, our slope is equal to our rise over our run. Well, our rise, okay, we're going to look at our rise. From this point here, this value here up to here, we have a rise of 5, okay? It's going from y is, or sorry, not 5, of 3, because we're going from y is 3 up to y is 5, so that's a rise of 2. Because right here we're at 2, and then we're going to go all the way up to 5. So that's a rise of 3, a distance of 3. And your run, okay, we're going from over here at -6 all the way over here to 3. So your run, okay, is 9. However, we need a negative on one of these because as you're changing, for example, as we're going from 3 over to -6, we're moving negatively. So it's actually a -9. So then your slope, oh, they want to do it both ways. So our rise on this side is also 3. Oh, I see what they're doing. Hold on, guys. Let me start over. My bad, my bad. Hold tight, hold tight. I'll fix it. Okay, so if you notice, okay, so your rise going from a +5 up here down to a 2 here is actually you're decreasing. So you have a rise of -3 in this direction. And then your run for that is going from here at -6 over to 3. So that's a +9. You're changing a +9. Your rise, if you're going from this point up to here, is actually going from 2 up to 5. So you've got a +3 if you look at it that way. And your run, if you go from here over to here, is actually going from the x value 3 all the way to -6. So you're actually changing -9, okay? And it does not matter which point you start with, the slope's going to be the same, okay? So technically our slope in this point, it's going to be our rise over our run. So we need to pick only one of them can have a negative in this case. So we would match this rise with this run. So it would be 3 over -9, which simplifies to -1 over 3. Okay, the slopes for horizontal and vertical lines. So if you have a vertical line running up and down, there's actually no slope, and we say that this is an undefined slope. Technically, there's not even a steepness. It's going up and down. If you have a horizontal line, there's actually a run here, but there's no rise. So this slope is 0. So that's something to really keep in mind here. So if you have an up and down vertical, it's undefined. But if you have a horizontal line, the slope is just 0. So again, things to keep in mind. We can tell if it's a positive slope if it's leaning up in this direction. Negative slopes lean over to the left. 0 slopes are anything running horizontally. And then undefined slopes are anything running vertically up and down. So we're going to tell whether the slope of the line is positive, negative, 0, or undefined. Well, if you look, because it's leaning up to the right, this is a positive slope. It's rising from the left to the right. In this one, the line is falling from the left to the right, so it's negative. So this, we have a vertical line. So if it's a vertical line up and down, it's not 0, it's undefined. So be careful with that. Know that this is undefined. And then we have a line that's going up from left to right. So this is a positive slope. Okay, last slide. When you're comparing slopes, in order to tell which line is steeper, we look at the absolute value. So for example, this line compared to this line, the first line has a slope of 1/2 and the second line has a slope of 4. So the one with the greater absolute value, the slope of 4, is the steeper line. For this next one, if you look, this first line has a slope of -2 and this one has a slope of -1. You have to look at the absolute value. And so because the absolute value of -2 is steeper than -1, that is why the -2 line actually has a higher slope. And then on this last one, the red line has a slope of 3/4, the blue line has a slope of -3. But because we look at the absolute value, the blue line, even though it's -3, the absolute value is 3, it's actually a steeper line. So again, the bigger the absolute value, the steeper the line, or the steeper the slope. If I can fit this on here. Okay, so the big thing from this lesson is to remember that the slope is equal to your rise over your run, or your change in y over your change in x. Okay, and we're done.